Welcome back to the next session of Design of Pre-Stressed Concrete Elements course. So in the last session, we have been started with module number 5, that is composite sections. In that, we have been discussed what is composite construction or what is composite sections and what are the different types of composite section or different types of composite construction we are going to do in order to construct or we are going to come across in the composite section. And later on, after coming to know about these types of construction, that is proper construction, unproper construction, all those things, and also we have been come across the two sections, okay, that is precast section and cast in situ concrete slab. Okay, so in this particular context, I have been discussed a very important thing, that is behavior, because when I want to join the two elements or materials or sections, it is not so easy to go through it. So hence, when I want to conjunction this or combine these two precast slab and the cast in situ sections, then then I need to go ahead with some preliminary preparations. Okay, so that is how these particular materials, that is sections, that is precast, pre-stressed units and cast in situ slab behaves. Okay, so those concepts are being discussed. That means roughening the top surface of the precast and then double action, that means extending the rod from the precast, and that is called shear connectors. So those shear connectors will be joined in conjunction with what I can say the cast in situ slab. Okay, so all these concepts we have been come across from the last session. So we'll move on to the next topic in the module number 5, a very important thing, that is analysis of composite sections. Analysis of composite sections. So, as I stated, before going to the analysis, one must understood properly what is composite sections, and what are the types of composite section and behavior. So now you can very easily understand the analysis part, because when I'm going to explain each component, so that you can will be more familiarized in this particular topic. Okay, so let us go through this. So now, coming to the analysis, as I stated, that means this composite section will be subjected to the what I can say bending. So when the composite section, that is precast section in conjunction with cast in situ concrete, if I am going to cast it, then this particular composite section will be subjected to bending. What are the various stresses? What are the various stresses you are going to come across in particular to the type of composite construction? Did you get my point? So that means the composite section analysis, will be vary based on the type of composite construction. That is, whether it is proper construction or unproper construction. So based upon unproper construction and proper construction, the composite section analysis will be varied and the stresses encounter will be varied. So those concepts I am going to explain today in this particular analysis topic. So as I stated, so the analysis for a composite section such as the stresses developed in precast unit and or precast pre-stressed unit and cast in situ slab will be what I can say explained or computed using simple bending equation. Will be computed using simple bending equation. That means we are going to analyze the composite section subjected to flexure. Subjected to flexure. Is it clear? So now this analysis, that means the stresses developed in this precast pre-stressed unit and the cast in situ concrete slab, okay, will be computed using simple bending equation. So we know that what is the simple bending equation? Okay, that is M by E is equal to E by R is equal to F by Y. That is the same bending stress formula which you have been used from the strength of materials. Okay, that is Bernoulli's bending equation. So the same Bernoulli's bending equation, okay, holds good here also while performing the analysis for composite section under flexion. Okay, so let me move on to the next. So now, as I stated, the analysis for composite section, okay, or the stresses in the composite section will be vary based on the type of a composite construction. So let me go with the first one. So that is unpropped composite construction. So when I am going with uncomposite construction of, that is unpropped composite construction of this precast pre-stressed unit and sulfate of cast in situ slab, what are the stresses will be encountered? So now, so you know what is the meaning of unpropped first. Unpropped means the precast pre-stressed unit will not be propped or will not be supported while placing the cast in situ concrete slab. So that is called unpropped construction. I will repeat, if precast pre-stressed unit is not propped or not supported, okay, in order to taken care of sulfate of that member and the placing of cast in situ slab, okay, while placing the cast in situ slab. So that type of construction is called unpropped construction. So now let me know what are the stresses that will be encountered during unpropped. The stresses developed are okay, the stresses developed are number one, the first will be self weight of the member. Self weight of the member. Okay. That means precast pre-stressed section. So this is the first stresses we are going to get. It means stresses developed due to the self weight of the precast. Next, self weight of the cast in situ concrete. Self weight of cast in situ concrete. Okay. Next, C, that is one more thing. Okay. The next is pre-stressing force acting at given eccentricity. Pre-stressing force acting at given eccentricity. So these are the various components, okay, in which I am going to consider in order to analyze the composite section under the unpropped case. Under the unpropped case. Or else when the composite section which is unpropped, if I want to analyze that unpropped composite section, then these are all the things I need to consider in order to calculate the stresses. Number one, self weight of the member. That means self weight of the precast pre-stressed unit. That is the first thing. The second thing is self weight of the cast in situ slab. That means when the prepared, precast pre-stressed unit which will be prepared in the factory or manufactured in the factory, which is brought to the site, and then which will be unpropped. So that is self weight. So that's self weight. That's one self weight. On above that, I am going to place the cast in situ concrete slab. This cast in situ concrete slab which I am going to place on above the precast pre-stressed unit. After bringing the precast pre-stressed unit to the site which will be casted in the factory. Later on, this cast in situ slab will be placed on above the precast pre-stressed unit in such a way that this cast in situ slab, which is going to cast in the site itself. At that particular instance, the self weight of this member will also be considered while analyzing the composite section under unpropped construction case. Because the self weight of this member will also come into the picture. And one more thing, while placing the cast in situ concrete slab, this precast pre-stressed unit member will not be supported, will not be propped. So that is the one, these are the two stresses. Apart from these two stresses, we already know that, we from the basic principles of the pre-stressing from the module number 1, in the precast pre-stressed unit, that means while manufacturing the precast pre-stressed unit in the factory, in the prescribed distance, that is eccentricity, at a eccentricity, I am going to induce, a pre-stressing force, to this precast pre-stress section, I am going to induce a pre-stressing force at a particular distance. So that is the one more thing. That is pre-stressing force acting at given eccentricity. So these are the three things I need to consider in order to perform the analysis for composite section under unpropped construction case. Did you get my point? So as I stated, analysis means we are going to calculate the stresses. Analysis means we are going to calculate the stresses. Stresses for what? Stresses for composite section. Due to what? So the composite section due to the self weight, of the cast in situ and the pre-stressing force acting at the given eccentricity. Did you get my point? And apart from this, now, so this is regarding the casting case. Now come to the very interesting thing. So now, after this hardening, that means once if I am going to combine these composite section elements, that is precast pre-stressed unit and the cast in situ slab, that means after casting, then once if the composite section hardens, then this composite section will be subjected to the live load. That means after hardening of composite section, it will be subjected to the live load stresses. That means, now come to the very important case, that is live load stresses. Live load stresses, for composite section. Live load stresses for composite section. So these are all the stresses that will be encountered, in the unpropped composite sections while performing that. That means these are the things I need to consider. So this thing before hardening and this will be during hardening process. Or after hardening process. After hardening process, the composite section will be subjected to the live load, and before hardening, so these are the stresses I need to consider. So now based on this, let me write down the stress, diagram for these components, or these parameters. Let me write down the stress diagram. So how that these particular stresses will vary. Let me go ahead. So now let me start with this, drawing the stresses diagram. So first, let me draw the cast in situ concrete slab. Let me draw the cast in situ concrete slab. Okay. This cast in situ concrete slab will be resting on precast pre-stressed unit. Okay. So we'll be resting on precast pre-stressed unit. Okay. So this will be cast in situ and this will be precast pre-stressed section. Okay. And now as I stated, okay, so let me draw the things one by one. So now as I stated, okay, the first thing, okay, the stresses encountered will be, okay, will be due to the pre-stressing force induced. Okay, so as I stated, okay, I am going to induce the cable, okay, and induce the cable at a particular distance. Okay, I am going to induce the pre-stressing force at this particular distance. So because of this, okay, it will develop the initial pre-stress, okay, which is 0 at the top, okay, and okay, what I can say, the complete, it will be compressive in nature, okay, which is called initial pre-stress. Okay, which is called initial pre-stress. So these stresses will be developed due to the pre-stressing force induced, in particular to the precast pre-stressed unit. Okay, so pre-stressing force developed due to the precast pre-stressed unit. So now the very interesting thing, okay, that is going to happen is, so now whatever the pre-stressing force that will be induced, okay, whatever the pre-stressing force that will be induced, so those pre-stressing force, okay, will encounter some amount of losses, or whatever the pre-stressing force have been induced in the precast pre-stressed section, okay, we come across certain amount of losses. So those losses, okay, neglecting those losses, okay, the left out or the net force will be called effective pre-stress. Okay, so because of that effective pre-stressing force, okay, once again the stresses induced will be effective pre-stress. So this is also compressive in nature and this will be called effective pre-stress. Effective pre-stress means, okay, have been defined in module number 1, 3 and all. So effective pre-stress means, okay, the pre-stressing force or net pre-stressing force available after the loss of pre-stress as encountered in the precast pre-stressed section. Please note this point, a very important point, because I am going to induce the pre-stressing only in the case of precast. So that's why, okay, I am going to limit the stress diagram to this level. Please note this point. Okay, this pre-stressing force induced only in the precast, hence the stresses encountered will be stopped at this junction. Is it clear? Okay, and whatever the initial pre-stress that will be induced, which will be compressive in nature, okay, later on, because of the losses encountered, the net effective pre-stressing force will be expressed as effective pre-stress. Is it clear? So next, coming to the next thing. So plus, that means addition of, okay, Next is, we'll move on to this. Okay, we'll move on to this. And whatever the thing, I think effective pre-stress have been written, this is one. Pre-stressing force acting at given eccentricity. So this is what? Pre-stressing force acting at given eccentricity. Because of this, initial pre-stress will be considered. If the losses is encountered, because of that will be effective pre-stress. So this is over now. Next, we'll move on to the next stress. That is stresses due to self-weight of the member. That is precast pre-stressed unit. So as I stated, okay, it will be subjected to bending. The variation will be like this. Okay, positive, negative. Because I have been told this case, okay, once, okay, the self-weight, okay, will be coming to the picture. In the case of any section, the bending stress diagram will be, okay, positive at the top and negative at the bottom. That means compressive stresses will be developed at the top and tensile stresses will be developed at the bottom due to dead load. I think this particular case have been explained in the module number 1 also. When the section is subjected to bending, okay, when the section is subjected to bending, that is due to dead load, okay, then automatically the compressive stresses will be developed at the top and tensile stresses will be developed at the bottom. Same thing holds good here also. Next. Next, this is over now. Self-weight of this over. Next is self-weight of the cast in situ concrete. Okay, stress due to self-weight of the cast in situ. Now once again, okay, since it is a thing, okay, I am going to write down. Like this. So once again, okay, I forgot to write down, sorry. Stress due to self-weight of precast pre-stressed unit, and this will be stress due to self-weight of cast in situ concrete. Okay, so now this particular bending stress is due to the self-weight of the cast in situ slab, which will be considered while performing the unproper composite section analysis. Okay, so this is one more thing. Okay, next. So this is also over now. Okay, so now I have been draw the stress diagram for, okay, these parameter, that is before hardening. Okay, while erecting the precast section and while casting the in situ concrete slab. So these are all the stresses that will be encountered. So those stresses are stresses due to the pre-stressing force at given eccentricity. Next, stresses due to the self-weight of the precast. Next, stresses due to the self-weight of the cast in situ. Is it clear? Okay, stresses due to the self-weight of the cast in situ, okay, bared by precast. So that's why I've written here. Okay, stresses due to the self-weight of cast in situ slab on precast. Okay, next, we'll move on to the next. So the next is live load stresses. See, once the concrete hardens or the composite section hardens, okay, the next thing is the stresses will be developed. That means once the section hardens, as I stated, this composite section should behave as a monolithic unit. Am I right? So because that is what my motto of a composite section. Okay, that is what the aim of a composite section. So when I am going to cast this thing, okay, the cast in situ concrete slab and the precast pre-stressed unit should perform as or should structurally function as one single unit or monolithic unit. Okay, so because of this, okay, so one, that means if it get hardens, okay, then the composite section will be subjected to the live load. So now live load stresses. So the live load stresses I will be starting from here. So this will be the live load. So positive, negative. So did you get my point? So now, okay, so these stresses will be encountered, stresses due to live load of a composite section, because till it is not properly joined, that is precast and cast in situ, it will be not allowed for the movement of a traffic, because as I stated, mainly this composite section will be used for bridges or highway, bridge decks, so hence till this function as a monolithic unit, I will not be subjected to any live load. So once this composite section hardens, then this composite section will be subjected to the vehicular movement or the live load. So because of that live load, so this is the stress developed. So finally, if I sum up all these things, that is stresses due to the effective pre-stressing force, that is pre-stressing force at given eccentricity, stresses due to the self-weight of the precast pre-stress unit, stresses due to the self-weight of the cast in situ concrete slab, next stress due to the live load of the composite section, then I am going to calculate the resultant stresses, which will be predominantly compressive in nature. So it will be something like this. So just I have drawn the shape. So this shape you are going to know once you are going to sum up all these things. So this is the pattern you are going to get. So whatever the diagram I have been drawn, that is the pattern. So this will be the resultant stresses obtained after performing the analysis under flexion. So hope you have understood. And you need to calculate here, what is this distance, what is this distance, what is this distance, everything you are going to calculate from these two analysis. So this is what the stress distribution diagram you are going to come across when you are going to perform the analysis. In the problem also the same thing you are going to do. So they will give the problem, analyze the section for unproper case, then you need to calculate this, then this, then this and this. So finally resultant stress. That means you need to calculate each component, that is first self-weight of the member, next self-weight of the cast in situ, pre-stressing force, next finally live load. So once if I sum up all these things, the final thing will be your resultant stress. Anyway, I am going to work out the problem. So at that particular instance, you will come across numerically how to draw these things. But shape of the stress diagram remains same, almost same. Is it clear? So we will move on to the next thing. The next thing is the proper construction. So next thing is proper construction. So now the same composite section. So what is the meaning of proper construction? That means the same precast pre-stressed unit will be propped. In composite construction, if precast pre-stressed unit which is brought from the factory, which will be propped or supported while placing the cast in situ slab, then it is called proper type of composite construction. Did you get my point? So while placing the cast in situ concrete slab, if I am going to prop the precast pre-stressed unit, then it is called proper type composite construction. Is it clear? Next. So we will discuss now one by one. So what are the stresses encountered in proper case? So now, let me go with the precast. If the precast unit is propped during the placing of cast in situ concrete, the stresses developed are, the stresses developed are. The first thing, the same thing, that is self-weight of the member. The same thing, self-weight of the member. No change in this. Okay, no change in this. Next, pre-stressing force at given eccentricity, that is also same thing. Okay, no change. Pre-stressing force at given eccentricity. So this is also same. Next, coming to the, what I can say, self-weight of a catch-sensitive concrete. Okay, so now, once again, write down self-weight of the cast in situ concrete. So now, in the stresses developed in the self-weight of the cast in situ concrete, okay, so this is the one change you are going to come across in the case of prop. That means, okay, you can see the stresses encountered in the case of a, what I can say, the cast in situ concrete, okay, which will be unpropped case. Now, for a propped case, the stresses encountered for a cast in situ concrete slab will be considered, okay, based on the composite section. Please note this point. So now, self-weight of the in situ concrete will be considered based on the precasting in the case of unpropped. But in the case of propped construction, for a same section, that means if I am going to support this precast, then the self-weight of the cast in situ slab will be considered by considering the whole composite section. Okay, because of providing prop or because of supporting the precast, okay, the stresses developed due to the self-weight of the cast in situ concrete will be calculated or computed using or considering the whole composite section. Did you get my point? So that's why stresses developed due to the self-weight of the cast in situ concrete are computed using the sectional modulus. That's what? Sectional modulus of the composite section. I will write down. Are computed using sectional modulus of the composite section. Okay, this is the one change in the case of prop case. Because of providing prop to the precast pre-stressed unit while placing the cast in situ concrete slab, I am going to consider the entire composite section. That is what? The sectional modulus of the composite section will be considered in order to calculate or compute the stresses developed due to the self-weight. So because of that, the stress diagram will vary. I will write down now, okay, how it will vary. Okay, so next, once again, the same thing, okay, the last, same thing. So once the composite section hardens, finally, the composite section will be subjected to live load stresses on the composite section. Live load stresses on the composite section. Okay, so same thing. So once the composite section finally hardens, then the composite section will be subjected to the live load. Okay, the only change in this particular case is this. Okay, so now first I will explain that. There is one more change, I will explain later. So now, the same thing, the same section I am going to consider, which is T section. Okay, that is rectangular precast pre-stressed unit and rectangular cast in situ concrete slab, which will be, okay, combined to form a composite. Next, at a particular distance, okay, from the centroidal axis of a section, okay, I am going to induce the precast pre-stressing force, okay, at a particular eccentricity. So because of that pre-stressing force, okay, it will, okay, the stresses developed are the initial pre-stress. Okay, so once the losses are encountered in the precast pre-stressed unit due to maybe creep, shrinkage, electric deformation, all those losses. Because of that, okay, after, okay, and considering that losses, okay, the finally left out or the net, okay, pre-stressing force, okay, based on that, if I am going to calculate the stresses, so that is called effective pre-stress. So please note this. That means this effective pre-stress will be calculated based upon the percentage loss or loss ratio. By considering the loss ratio for this initial pre-stressing force, we are going to calculate the effective pre-stress. Is it clear? The same thing we did in module number 1 and also module number, okay, 2 also, okay, in the while performing the loss of pre-stress. The same thing holds good here also. Next, stresses due to the self-weight of the precast pre-stress, no change this. Okay, because as I stated, the self-weight of the member or self-weight of the precast pre-stress, no change in this. Next, the change in this particular thing is as I stated, so since precast pre-stress unit is propped, okay, while placing the cast-in situ concrete slab, I am going to consider the entire composite section in order to assess the stresses due to the self-weight of the cast-in situ concrete. So hence, so please note down, the stress diagram will vary from this point because of considering the composite section, okay, the variation will be like this. So this is the only change because I have clearly written that self-weight of the cast-in situ concrete slab are computed using the sectional dimensions of composite section. Earlier, I used to calculate based on the sectional dimension of a precast pre-stressed unit. Now, I am going to calculate the self-weight of stresses due to the self-weight of cast-in situ concrete slab by considering the sectional dimension of a composite section. This is the only change, okay, or first change or one change you come across in the case of propped and unpropped case. Propped and unpropped case. Okay. Next, as usual, so once the concrete get hardens, so as I stated, okay, it will be subjected to the live load. Okay, then this is the live load stresses developed due to that remains same. And finally, I am going to calculate the resultant stresses developed, okay, or obtained in the composite section, okay, in particular with propped construction case. In particular with propped construction case. Is it clear? So hope you have understood the difference between unpropped and propped case. Okay, you come across the difference. So this is the one change, okay, you come across. Okay, in the case of unpropped, you are going to consider the sectional dimension of the precast pre-stressed unit, okay, in order to calculate the stresses due to the self-weight of the cast-in situ. But in the case of propped composite construction, you are going to consider the sectional dimension of the composite section in order to calculate the stresses due to the self-weight. Hence, okay, you can observe the change in stress diagram. I have been consider the entire composite section. Is it clear? So this is the one change. Okay, and one more change you come across in the case of propped construction is, or while performing the analysis is, so as I stated, because of different grades of concrete used in the case of precast and cast in situ. Okay, as I explained in yesterday class, the grade of concrete used in precast is different and cast in situ is different. For example, in precast, okay, I am going to use 35 to 45 MPa. But in the case of cast in situ, I am going to use 20 to 35 MPa. Because of this variation in grade of concrete, the modulus of elasticity of concrete will also vary. Please note this point. It is very, very important. Okay, because of variation in grade of concrete, the modulus of elasticity of concrete, okay, in cast in situ and also in precast pre-stress unit will vary. Because of this variation, particularly in the case of propped construction, okay, we are going to, okay, conduct the analysis, okay, in the different way. That is, okay, I will go to explain. So I will read out. So for computing the, especially, okay, so when the grade of concrete changes or the modulus of velocity changes, then the live load stresses will change. The calculation of live load stresses will change. This is the one more change. Okay, so how the live load stresses, okay, will be considered, okay, will be calculated, okay, by considering the modular ratio of precast unit and cast in situ concrete slab. That means by considering the modular ratio, that is modulus of velocity of precast to the modulus of elasticity of cast in situ. So this ratio you need to consider while calculating the live load stresses on composite section. If you come across, okay, the modular ratio variation. For example, if the modular ratio is equal to 1, which implies what? That means the modulus of velocity of cast in situ and modulus of velocity of precast is same. No need to worry, it remains same. If the modular ratio, that is modulus of velocity of precast and modulus of velocity of cast in situ concrete slab varies, maybe 0.8, something like that. At that particular circumstance, the live load stresses calculation varies. At that particular instance, how to calculate? The live load stresses will be calculated for a composite section by considering, okay, or by calculating the area. That means, okay, this modular ratio, okay, we need to multiply to the area of a composite, moment of inertia of a composite, okay, and then whatever the thing, centroid, okay, sectional modulus, everything. We need to multiply this modular ratio factor, okay, to the composite section. Later we need to perform or calculate the live load stresses. So these are all the two things you need to understand. If they are not being mentioned, anything like, okay, modular ratio is same, no need to worry, very simple, you just go through it. If modular ratio differs, live load stresses will also differ. Please note this point. That is one thing. And another thing, in the case of propped construction, while calculating the stresses due to the sulfate of cast in situ, you need to consider the entire sectional dimension of a composite section. Is it clear? Okay, so you need not to worry much about unpropped case. You need to worry much in the case of propped construction. You need to be very careful in these two cases. One is sulfate of the cast in situ concrete slab, and another is modular ratio variation. These are very important. So in the problem, while performing the analysis, you need to observe these two things, and then you need to proceed with the problem. So these things I am going to teach you in the next session. Okay, so hope you understood okay, how to perform this analysis, okay, in the case of propped construction and unpropped construction. Hope you have clearly understood. So with this, I am going to end this session. We are going to discuss the various problems or perform the analysis, okay, in the context of propped construction, unpropped construction, modular ratio variation. So we will go through the various conditions. So with this, I am going to end the session. Thank you.